Hey Shivapriya, as we all learning about microprocessor, let me give you a small introduction about microprocessor.
Okay, you will.
Okay. It is a computer processor for which the data process, logic and control is included on a single integrated chip. So we can perform each and every operations in a single integrated chips. So it contains arithmetic, logic and control operations required to perform the functions of the computer, CPU. So it is the multi-purpose, clock-driven, register-based circuit. This accepts data as a form of binary values as an input and processes it according to the instructions stored in the memory. So, do you know before the invention of microprocessor, what are we used?
Clearly, I don't know. You may tell.
Okay. Before microprocessor, a small computers has been built using racks of circuit boards with many medium and small scale integrated circuits. The first commercially available microprocessor was the Intel 4004, which was designed by Federico Fogge and introduced in 1971. So also the microprocessor is a distinct form of a microcontroller, including a system of chip. So now we have seen a small introduction about microprocessor. We'll see about the speed and considerations of the microprocessor. Definitely when we are building a microprocessor, speed and considerations are very important and it plays a key role in the microprocessor. So the microprocessor can be selected based on their word size, which is the measure of their complexity. So longer word size allows each clock cycles process to carry out more computation, but the corresponding to physically large integrated circuits dies with the higher standby and operating power consumption. So we can't give the highest power consumption because it cannot stand by. It cannot go through that amount of current. So not only in personal computers, the microprocessor was also found in smartphones and other electronic devices.
Okay, I will tell about the evolution of microprocessor.
Okay, Shivapriya, carry on.
Okay. In 8080, it was the world's first general purpose microprocessor. So it was an 8-bit machine with an 8-bit data path to memory. It was in first personal computer also.
Okay, only a 8-bit data, they have invented only a 8-bit data?
No, it may 64-bit, 16-bit processor also available.
Okay. Can you explain me about that?
Okay. In 8086, it was a 16-bit machine. So and more powerful than previous. It had a wider data, but 16 bits and a larger register along with an instruction cache. Then 80386, it was the Intel first 32-bit machine due to the 32-bit architecture also. It was able to compute against the complexity and the power of microcomputers introduced just a few years later. Then 80286, it has an addressable memory of 16 MB instead of just 1 MB. Then so many processors also is there. That was Pentium Pro, Pentium First, Pentium 4th, 5th, etc. Then let me about tell about the architecture of 8086.
I don't know more about architecture. You can explain me so I can also gain some knowledge about the architecture of 8086.
Okay. The 8086 microprocessor is a 8-bit or 16-bit microprocessor designed by Intel later 1970s. So it includes many CPUs used in personal computers. The architecture of 8086 is based on computer instructions, then set computer like CISC, so it supports wide range of instructions. So it has 20-bit address bus which can add up to 1 MB of memory and 16-bit data bus which transfers the data from the microprocessor and many memory IO devices also. So it has a segmented memory architecture, which means the memory is distributed distributed into segments that are addressed using both the segment register and an offset address also. So it has two main units. Basic components is there. What are the components are bus interface unit and the execution unit.
Okay, Shreya. Can you explain about these two?
Okay, I will explain. Bus interface unit, it is the fetches the instructions from and the data from memory and I/O devices. So contains the instruction queue which prefetches instructions. Houses the segment registers like CS, DS, ES, SS. So generates the physical memory address and execute it.
So there are also 8-bit registers and 16-bit registers, right?
Yes. So then executional unit. It is a decodes and executes instruction fetches by BIU. Contains ALU which performs arithmetic and logical operations. Includes general purpose registers AX, BX, CX, DX then also. So for data storage and calculations. Has each special purpose like SP and flag registers for status information. So 5 generations are there. First generation is 4-bit microprocessor like Intel 4004.
Then they have developed at the first they have developed a 4-bit microprocessor.
Yes. First, okay. Second 8-bit processor like 8008 and 8080. Then third generation 8086 offering increased memory address. So then fourth 32-bit address 80386. Then fifth generation 64-bit processor.
Okay. Till now, modern computers are using a 64-bit processor.
Yes.
Okay, sure. As we seen about the microprocessor, the microprocessor are not only in computers; it was in many fields, right? So for the first, the microprocessor was available in AI, in the field of AI. For example, when we speak to Alexa, ask Google Assistant to we'll ask the questions. No, we can communicate with the Google Assistants or Alexa. When we speak, it will respond, right? So that recommends some movies or we ask whatever we ask, they will recommend something, right? So we are interacting with the AI models. Behind those AI models, we need a powerful microprocessor to do all these works, to make things work. So modern AI needs fast, parallel, and specialized chips come in. So here are the specialized chips like graphics processing unit, tensor processing unit by Google. So these chips process a huge amount of data in real time. So in facial recognition, a phone scans your face and compares it to stored data within a millisecond. So this much fast the microprocessor works. Without the powerful microprocessor, we can't do these things. Okay. Not only in AI, it was in various fields.
It was used in various fields like companies.
Yeah, like electric vehicles. Not only in AI, it was used in many fields, right? So in coming to the electric vehicles, for example, in Tesla, autopilot system runs on custom AI chip that processes video from 8 cameras, 12 ultrasonic sensors and radars simultaneously. So in electric vehicles, one processor manages battery health, another controls motor speed and acceleration, etc. It can do many things, but a separate chip can handle functionalities in these. In IoT devices, it includes devices like smartwatches, fitness bands, smart bulbs, voice assistants, home security systems. It was used in various devices which we are using in our day-to-day lives. So it is very useful, right? Without microprocessor, we can't use anything. So now they were developing a lot of powerful microprocessor. So in our day-to-day life, we are using it. It contains a low-power microprocessor that processes data, sends signals, and connect to Wi-Fi or Bluetooth. So in IoT device, rather than this AI field, it also included in healthcare industry. So wearable ECG monitor tasks, heart health in real time. So it is heart health in real time. Okay. Insulin pumps, automatically adjust the dosage on reading. So it is also used not only in these things, it is also used in surgical robots. So we have many instruments in the surgical robots, like many instruments. In these instruments, the microprocessor has been used. So also in smart factories, it manages robot arms, quality checks, and they monitor temperature, vibration, and speed to reduce downtime and boosts the efficiency. So Shubhapriya, as we seen in about the basic about microprocessor and in what are the fields it was used, do you have any idea in future what are the things can be developed about the microprocessor?
No, I have no idea about that.
You have some of the ideas like in the few industries.
I think AI-powered processor, quantum computing,
Yeah.
these fields maybe increased the use of microprocessors.
Yes, sure, you are right. I will explain about it.
Okay, explain.
In heterogeneous computing, combines different types of processors like CPU, GPU, NPU, and DSP on a single chip. So it is used for a better power efficiency and performance. While we are combining all these chips, so you can imagine like how powerful it works, and the performance increases very fast.
Okay.
So in AI power processor, future microprocessor, maybe in future it can build in machine learning accelerators. Maybe it can be faster neutral net processing, cause and phase recognition. Comparing now, in future maybe it improves its performance and lot of things can be improved in their microprocessor. So in quantum computing, the processors like IBM, Intel, Google aim to perform operations on a classic chip. So still experiments are going through to improve the performance of the microprocessor. So neurophobic chips mimic the brain's neural structure. Using chips, we can control our brains. We can do lot of things. In future, maybe we can control our brain signals using a minute microprocessor. See how the technology is going to develop. Yeah. Also in security first designs, the cyber threats rising future microprocessor will be embedded. So hardware level encryption, zero trust architecture also can be developed. So in energy efficiency and green computing, it focuses mainly on to reduce the power designs, wearables, IoT and sustainable computers. So I only know these things about it. Do you know, can you tell about me in future what are the things is going to happen other than I told you?
Okay, I know few things about in future development. So first 3D chip stacking. This is what a traditional 2D chip factory space and has a heat limit. So future uses is 3D stacking, putting chip on top of each other. Then improves speed and
By
reduces.
keeping the chips, instead of keeping the chips separately, we are going to put each and everything in a single thing.
Yes. Then improves speed and reduces later between components. Then edge computing with a smart microprocessor. So it is microprocessor are moving closer to data sources. Smart cameras, drones, vehicles, industrial sensors, these things are used. So edge processor and enable real-time decisions without sending data to the cloud. So proves data locally. Then open source microprocessor architecture. This was RISC V. Open and flexible instruction set architecture. So it allows startup such as and government to build automatically custom processors. So compete with standard like 86 and ARM processor also.
Okay, sure, Priya. We are talking about the various fields which was microprocessor are used. So we can also tell about what are the companies that were using the microprocessor.
Okay, I know some companies use microprocessor. I know some microprocessor-based companies.
Okay, sure, Priya.
Okay, I will tell.
You can explain.
Okay, consumer electronic companies. This is what the companies like Apple, Samsung, Sony. Apple is used in iPhones, iPads, Apple Watch. Then Samsung is smartphones, televisions, tablet, these and all, etc. Then Sony is camera. So Dell laptops, desktop using Intel and AMD processor. So then automotive based companies. Automotive, this is modern vehicles are loaded with electronics. So that was microprocessor for controlling systems. This is the companies are Tesla. Tesla is used for autonomous driving, battery management. Then Toyota, BMW is engine control units, navigation and airbags. Then medical equipment manufacture. Microprocessors are used in imaging, diagnostics and patient monitoring. The companies are GE Healthcare, like CT, MRI scans. This and all used microprocessor. Then,
I also know some of the companies, microprocessor based companies that
okay, you
industrial
can explain. Okay.
used for control and monitoring and robotics. The companies were Honeywell, which building automation safety systems and examines PLCs, programmable logic controls and automation. So these companies are using microprocessor based on their based on industries. So can you tell about what are the functionalities of the microprocessor?
Okay, microprocessor based companies are mainly used for functioning only. So control motors, light, sensors, etc. Communication is computation, perform calculation for logic. Communications handles data transfer like USB, Wi-Fi, these things and all. So user interface run operating systems.
As we all seen about these applications, there is one application which most of them are not known. So the microprocessor are also used in NASA Mars rover. The processor used was RAD750, the radiation proof microprocessor. It was used by NASA. What are the uses of this means that controls regular movement, science instruments and communication on Mars. Why it is rare means works in extreme space conditions. So if you are working in a space, we have to be very careful, right? So operates fully automatically. Okay, then sends data from another planet. It can also sense data from a separate planet to a separate planet. So it saves billions by surviving years without repair. So it is very efficient to use in space. These are also used in space that consumes less power. As we've seen from the introduction of the microprocessor, also we have seen the basics of the microprocessor and also the various types of companies that offering the jobs based on the microprocessor, and also in which we have discussed the various fields that are used, microprocessor are used. Thank you Shivapriya for explaining these things for me. And also we have discussed in future how can all be the microprocessor has been developed.
Thank you, Candace, for explaining these topics.
Thank you.